The Hartwell Witch computer became operational in April of 1951. Like most computing machines of that era, it uses punched paper tape as a method of reading in programs. Here you can see 5 of the remaining original 7 tape readers that were used with the Witch. The Witch uses a custom paper tape encoding based on the 5-bit Baudot code. All the basic alpha and numeric characters needed to create a program have a unique 5-bit pattern assigned, with each bit represented by a hole in the paper. Here you can see a paper tape being read directly at the tape reader. 5 separate pins extend through the open holes. Each extended pin closes a contact which is then used to decode the stored character. Because the paper tape system utilizes 5 bits, the input system is also designed around 5 bits and is generally referred to as the 5-wire input system. Decoded characters are then transferred to the storage registers or loaded as commands to be executed. This brings us to the question for the video. How does the Witch load its first commands to get started? In modern systems, the initial commands on the system are often stored as read-only memory or ROM. The ROM generally contains the codes executed first when the system is powered on or reset. These initial codes generally provide enough information to begin loading and running programs from another source. Digging around in some of the original design notes for the Witch, one document was marked as Initial Order Control. One section in this document provided some interesting clues. This specific section talks about a series of 6 relays, JA to JF, that are used to load 2 initial codes, 03101 and 02101. These codes represent the commands to locate block 1 on tape 1 and to transfer control to tape 1. From this information, I was able to locate the schematic page for relay set J, and I was able to locate the relays JA to JF. These are a type of relay common to the era known as a post office relay or a PO3000 relay. These relays were highly configurable and very reliable. The Witch uses a total of 566 post office relays for switching, logic, and control. The PO3000 relays were so popular and reliable that modern replacements for them still continue to be manufactured even today. So how exactly can a PO3000 relay be used as a boot ROM for the Witch? Looking closely at this section of the schematic, I was able to identify this configuration as a basic shift register. Shift registers are common in modern electronics, but this was the first time I had seen one implemented using relays. After setting 1 bit at relay JA, a set of 6 pulses applied to the relays walks the bit across the relays to JF. The second section of this implementation is the encoding of the characters. This section is a basic diode ROM, but instead of using diodes, it uses the post office relays. Each relay from JA through JF encode a specific character. Wait, that is 6 relays and 6 characters, but from the original documentation, the code that is first transmitted is 5 characters, 03101. Why the 6th character? Turns out that on the punch tape, commands are preceded with a space character to indicate the command follows next on the paper tape. So the actual contents of the ROM are the characters space 03101. The last section highlighted in the schematic shows an additional post office relay that connects the ROM section to the 5-wire input system that was described earlier. Once the commands from the ROM have been sent, the relay disconnects the ROM section. With this information, I was ready to attempt a replica of this setup. Using 6 4-pole double-throw relays, I recreated the wiring for the relays JA through JF. To help visualize the relay activity, I added a red lamp to each of the relays to show when it was active. For the 5-wire input system, I used 5 orange lamps to indicate when each bit was active. A red toggle switch is used to set the first bit, and a red push button to simulate the shift register pulses. Let's see this in action. For more information on any of the items discussed in this video, please visit whiche.org.